Hello everyone, welcome back to my channel again. I hope all are doing well. Today we are discussing the main points of electrostatics, electricity and magnetism. So first thing you have to remember or you have to study the definitions, the main definitions. The first is Coulomb's law. Coulomb's law you don't by heart or memorize as in the textbook. You know that Coulomb's law states like this. You can state Coulomb's law by just reading this equation. So don't by heart, don't memorize as in the textbook. You can state Coulomb's law by reading this equation. If you know this equation, you can state it. The force between the charge, the force between the stationary charge or the force between the static charge is directly proportional to the product of the charge and inversely proportional to the square of the distance between them. The force is directly proportional to product of the charges and inversely proportional to square of the separation between them. This is enough for the definition. So don't memorize as in the textbook. There is no need of that. So force between the static charge is directly proportional to the product of the charge and inversely proportional to the square of the separation between them. So you can easily write. Then another important definition, it is electric field. Electric field E equal to F by Q. So this also don't by heart as in the textbook. Electric field at a point is the force experienced per unit charge at that point. So just read this equation. Electric field at a point is the force experienced by the unit charge at that point. So electric field at a point is the force experienced by a unit charge at that point. So that is the definition for electric field. Don't by heart or don't memorize as in the textbook. Just read this equation. Electric field is the force experienced by the unit charge or unit positive charge at that point. So that is the definition for electric field. Then what do you mean by electric power? Electric power P equal to energy by time. Electric power or power, what do you mean by power? It is the rate at which work is done, or it is the electrical energy consumed in unit time. It is the electrical energy consumed in unit time. P equal to E by T. P equal to E divided by T. This is E, this is T. So electric power is the electrical energy consumed in unit time. Electrical energy consumed in unit time. So that is electric power. So electric power equal to electrical energy consumed in unit time. So you can define like that way. Then another thing, Ohm's law. Ohm's law. Ohm's law you can state like this. At constant temperature, you can state Ohm's law like this by only knowing this. At constant temperature, voltage across a conductor or the current flowing through a conductor is directly proportional to the voltage across the conductor. The current flowing through a conductor is directly proportional to voltage across the conductor at constant temperature. So don't forget to write at constant temperature because Ohm's law is valid at constant temperature. Ohm's law is valid at a constant temperature only. So the current flowing through a conductor is directly proportional to voltage across the conductor at constant temperature. So that is the statement of Ohm's law. Current flowing through a conductor is directly proportional to voltage across the conductor at constant temperature. Then Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction. That is induced EMF epsilon directly proportional to rate of change of flux. So Faraday's law of electromagnetic induction you can state like this: the induced EMF produced in a conductor is directly proportional to rate of change of flux, the rate of change of magnetic flux. So induced EMF produced in a conductor or in a circuit is directly proportional to rate of change of flux. If more the rate of change of flux, more will be the induced EMF. Less the rate of change of flux, less will be the induced EMF. So induced EMF is directly proportional to rate of change of flux. So these are the main definitions in this unit. Coulomb's law, electric field, electric power, Ohm's law, electromagnetic induction. So electromagnetic induction is what? Induced EMF produced in a conductor or in a circuit is directly proportional to rate of change of flux. So this way, by remembering these equations, you can state or define. You can state the laws or you can define a term. I hope you can clearly see the questions. Let me read the question. Two charged objects on insulating stands have charges of 3q and 5q respectively. The objects are distance r apart and exert a force F on each other. They are moved so that they are now 1 by 3r. What is the new force that they exert on each other? Options are F 1 by 3F, C 3F and D 9F. So look at this question. There are two charges, 3q and 5q. Initially they are separated by a distance of r, and between these two charges there is a force F, and now they are separated by 1 by 3r instead of r. Here the charges are not changed. 3q and 5q are the charges. Now the distance is becoming 1 by 3r. So 3q and 5q, they are remain same, and the distance only is changing. It is changing from r to 1 by 3r. So what will be the new force? So let me explain in detail. So initially the charges were 3q and 5q. 3q and 5q. They are separated by a distance r. Now the charges are remain same, that is 3q and 5q. But the distance become 1 by 3r. How it will affect the force? Early it was F. Early it was F. What will be the new force? Here the charges are not changing. Here the charges are not changing. Only the distance is becoming from r to 1 by 3r. So in my previous videos it is explained clearly. So here the distance is becoming 1 by 3r. Distance is becoming 1 by 3r. So force will increase. The force will increase. What is the reason? Here the distance is reduced. So force will never decrease. It will increase only. So how it will affect the new force? So you know that F directly proportional to 1 by r square. This is the equation. F directly proportional to 1 by r square, because the charges are remains rest. The charges are remain rest and they are not changing. The charges are remain same. The charges are remain same. So here the charges are remain same. So here the only variable is what? Distance. So you know that force is inversely proportional to square of the distance. Here the distance become 1 by 3r. So when you square 1 by 3r, when you square 1 by 3r, you will get r square by 9. For example, if I put like this, f directly proportional to 1 by, instead of r, it is 1 by 3r, the whole square, r by 3. So it becomes what? F directly proportional to 1 divided by r square by 9. This 9 comes as numerator. So here the new number which is adding to the force is 9, and that 9 is coming as numerator. So the force will be increased by 9 times. The force will be increased by 9 times. It will never decrease. It will never decrease. It will increase only. How it will affect? How it is increasing? It is increased by 9 times. So here when you put instead of r, that is r by 3 the whole square, r by 3 the whole square. So it becomes r square by 9, and 9 comes in the numerator. 9 comes in the numerator. So the other things are constant. Which are the other things? The charges and the value of k, they are constants. So they have no dependency on here. So here the only dependent variable is what? Distance. So we are including distance in the equation. So force is inversely proportional to r square. That is the first case. But in the second case, force is inversely proportional to 1 by r by 3 the whole square. So it becomes what? Directly proportional to r square by 9. So this 9 will come as numerator. It becomes 9 times the previous value. So other things are constant. The charges are constant, and the k value is already a constant. K value is already a constant. You can refer other videos which I developed before 2 weeks. It is in my YouTube channel. So by referring that, you can easily understand that. So the new force will be 9 times of the previous value. The new force will be 9 times of the previous value. We can go to the next question. Two identical small metal spheres on insulated stands carry equal charges and are distance d apart. Each sphere experiences an electrostatic force of magnitude F. The spheres are now placed at a distance of 1 by 2d apart. The magnitude of electrostatic force each sphere now experiences is 1 by 2f, f, 2f, 4f. So initially the charges are at a distance of d apart, and these charges are two identical charges. It is kept on a metal sphere, and now the charges are separated by a distance of 1 by 2d. How it will affect the force? What will be the new force? You know that in the previous problem, it was 1 by 3r. The force become 9 times. Look at this question. Here the charges are remain same, only the distance is changing. The distance become half d. The distance is becoming half d. So the distance is reduced. If the distance is reduced, the force will never decrease. The force will never decrease. So the option A is wrong. In the option A, the force is decreased. So option A is wrong, and option B, it also will be wrong. What is the reason? Option B is saying the same force. So the force will change, but the option B is saying the same force F. So that also will be wrong. Then option C and D. So in option C and D, the forces are increased. So which is the correct option? For that, it is very simple. You know that force is inversely proportional to square of the distance. Force is inversely proportional to the square of the distance. So here distance become half d. When you square half d, it becomes d square by 4. D square divided by 4. You are squaring the distance. Here the distance is becoming half d. So when you square half d, it becomes d square by 4. And that 4 comes as numerator. And that 4 comes as numerator. And the new force becoming 4 times the previous value. The previous value was F. Now the force become 4F. So the right answer is option D. The force is becoming 4 times the previous value. The last problem I am discussing completely. So in the beginning, the force was F equal to K. The charges are identical. So Q divided by D square. Equation number 1. In the second case, F equal to K remains same. Charges are same. Then distance become D by 2 the whole square. Equal to K Q divided by D square by 4. Equation number. Instead of that, the 4 will come as numerator. The 4 will come as numerator. It is equation number 2. It is equation number 2. Here the new force is putting as F1. So F divided by F1. Or you can take F1 divided by F. So F1 divided by F will be, F1 is 4K Q divided by D square divided by K Q divided by D square. So K Q divided by D square will cancel. Then the remaining is what? F1 divided by F equal to 4. So the new force F1 will be 4F. The new force F1 will be 4F. Or simply without doing this, it is a multiple choice question. So there is no need of calculating in this way, or there is no need of writing full steps. So in mind you can calculate it. So distance here it is d by 2. Distance is reduced. So force will never decrease. It will increase only. So when you square the distance, it becomes d by 2. D by 2 the whole square. It becomes d square by 4. And that 4 comes as numerator. So you can easily understand the new force will be 4 times the previous value. The new force will be 4 times the previous value. That way you can easily understand it. So that is a simple question. If it comes in the multiple choice or in a descriptive way, you can do like this and you can easily calculate it. We can go to the next question. The electric field pattern between two charged spheres A and B is shown below. Which one of the following statements regarding the charge on sphere A and B is correct? Option A, sphere A and B are both positively charged. Option B, sphere A and B are both negatively charged. Option C, sphere A is positively charged and sphere B is negatively charged. And option D, sphere A is negatively charged and sphere B is positively charged. So here you can see it. If you consider charge A, the electric fields are coming to it. And if you consider charge B, the electric fields are going away from it. So you learned in the theory, the field lines are going out from a positive charge and the field lines are going to the charge if the charge is negative. So here the sphere B will be positive and sphere A will be negative. So which is the option? Sphere A is negatively charged and sphere B is positively charged. So option D is the correct answer, because from B the field lines are going out, and if you consider A, the field lines are coming into the charge. So sphere B is positively charged and sphere A is negatively charged. So when you draw electric field lines, you must remember positive charge. If you consider positive charge, field lines are outward. If you consider negative charge, field lines are inward. Field lines are inward. So positive charge, field lines are outward. Negative charge, the field lines are inward. If you consider plus and minus charge, if you consider positive charge and negative charge together as a system, so from positive charge the field lines are outward and negative charge the field lines are inward. So it is outward, this is inward. So this is the field lines around a positive negative charge system. A positive negative charge system. From positive charge the field lines outward, negative charge field lines inward. If you consider negative charge, the field lines are inward. The field lines are inward and they will never meet. They will never meet. If you consider negative charge as a system, in both the charge the field lines are inward and they will never meet each other. If we consider positive charge, the field lines are outward. The field lines are outward and they will never meet. So in the question it can be positive negative charge, positive charge or negative charge. So only one thing you have to remember in mind: positive charge field lines are outward, negative charge field lines are inward. Don't draw in opposite way. So these things you must keep in mind. We can go to the next question. It is a descriptive question. Two metal spheres Q1 and Q2 on insulating stands carry charges plus 4 nanocoulomb and minus 12 nanocoulomb respectively. Distance you can take as 2 centimeter. Distance you can take as 2 centimeter. It is not given in the question. How will you calculate the force between them? How will you calculate the force between these two charges? This is the question. So two metal spheres Q1 and Q2 and their charges are plus 4 nanocoulomb and minus 12 nanocoulomb and they are separated by a distance of 2 centimeter. How will you calculate the force between them? It can be calculated by Coulomb's law. What is Coulomb's law? F equal to K Q1 Q2 divided by R square. Here Q1 is plus 4 nanocoulomb and Q2 is minus 12 nanocoulomb and the distance is 2 centimeter. So how will you calculate it? So we can do that problem. The charges are plus 4 nanocoulomb and minus 12 nanocoulomb. The distance is 2 centimeter. So two metal spheres. These are insulating stand. This is plus 4 nanocoulomb and this is minus 12 nanocoulomb and they are separated by a distance of 2 centimeter. How will you calculate the force between them? So here the one of the force is plus 4 nanocoulomb and the other force is minus 12 nanocoulomb. So we are considering only the magnitude. Here we are considering only the magnitude. So there is no need of putting plus and minus. So the force, the nature of the force always will be attractive because one of the charge is plus and the other charge is minus. That is positive and negative. Positive and negative will attract. So we are getting attractive force. What is the magnitude of that? How will you calculate it? So F equal to K Q1 Q2 divided by R square. R square. Then F equal to K value is 9 multiplied by 10 to the power 9. Then Q1 is 4 nanocoulomb. 4 multiplied by 10 to the power minus 9. Then don't take minus. There is no need of putting minus. Only take the magnitude. So 12 multiplied by 10 to the power minus 9 divided by 2 centimeter. You must convert into meter. That is 0.02 meter, the whole square. How will you convert 2 centimeter to meter? Divide by 100. So it will be 0.02. So don't forget here what? You must convert nanocoulomb to coulomb and distance should be in meter. So always in numericals, use the unit of charge as coulomb and the distance meter. If you forget that, your answer will be completely wrong. Your substitution will be wrong and your answer will be wrong. So here we calculated like that. So you will get an answer. I am not calculating that, I am just showing the method how to do it. And the answer you should write in Newton. The answer you should write in Newton. So you will get a value of force. And this force will be attractive because the charges, one is positive, another is negative. Positive and negative. So they will attract. So you are getting an amount of force which will be attractive. Okay, so what law here we are using it? K Q1 Q2 divided by R square, that is Coulomb's law, and K is 9 multiplied by 10 to the power 9. Q1 is 4 multiplied by 10 to the power minus 9 and Q2 is 12 multiplied by 10 to the power minus 9. Distance is 0.02 the whole square, and I am not doing the complete calculation with the answer. I am just showing the steps how to work out. So the answer will be in Newton and the force will be attractive. Here I am doing a numerical problem, that is force experienced by a charge by the two charges. For that I am considering an example. So here plus 3 nanocoulomb, 4 nanocoulomb and minus 5 nanocoulomb, and the distance are 2 centimeter, 3 centimeter. This is the first charge, this is the second charge, this is the third charge. Here we are calculating, here I am calculating the force experienced by the second charge, by the first and the third charge. So the second charge is experiencing a force from the first charge and third charge. So if I am considering first and second charge, this is plus, this is also plus. You know that positive will repel. So the second charge is repelled by the first charge. The second charge is repelled by the first charge. So the direction of force will be towards right, that is F1. So F1 will be what? F1 equal to K, that is 9 multiplied by 10 to the power 9. Then 3 nanocoulomb, you must convert into coulomb, that is 10 to the power minus 9. 4 nanocoulomb, 4 multiplied by 10 to the power minus 9 divided by the distance. Distance is 2 centimeter. Convert into meter, 0.02 meter, this square. So if you solve this, you will get a force. F1 equal to, you will get a value, that value will be in Newton, it will be towards right. So the second charge is experience a repulsive force by the first charge because both are positive. So the second charge is repelled towards right by the first charge. So F1 direction will be towards right if you consider first charge and second charge. Then I am considering the second charge and third charge. So the same equation, F equal to K, K 9 multiplied by 10 to the power 9. So I am considering as F2. First one is F1, second one is F2. The charges are 4 nanocoulomb. So 4 multiplied by 10 to the power minus 9. 5 nanocoulomb, 5 multiplied by 10 to the power minus 9. the separation 5 centimeter. So 0.05 the whole square. 0.05 the whole square. The separation was 5 centimeter. We are converting into meter. 0.05 the whole square. So you will get a force F2. That will be in Newton. That will be in Newton. That also will be towards right. What is the reason? Second charge is positive, third charge is negative. So the second charge is attracted by the third charge. Second charge is attracted by the third charge. So F2 also will be towards right. So here the second charge is experiencing two forces. The first force is given by F1 or the first charge, and that force is a repulsive force towards right. And the third charge is giving an attractive force on the second charge, and that is also towards right. So if you want to calculate net force, F net equal to F1 plus F2, right. Just add these two forces and the direction will be towards right. So here the second charge is experiencing an attractive force and repulsive force. Repulsive force is given by the first charge and attractive force is given by the third charge. So because these two forces, there will be a net force experienced by the second charge. So here the two forces are towards right. One is repulsive, another is attractive. So the second charge is repelled by the first charge towards right. And the second charge is attracted by the third charge towards right. Both are towards right. So the net force will be F1 plus F2 because both are in the same direction. So we are adding and giving the same direction. So this is the way how to solve this type of problem. So look at this question. We want to work out the cost of using a small oven 1500 watt for a total 1 hour in a day. The following steps outline what you should do. In step 1, write down the formula. Cost equal to power rating multiplied by time multiplied by the price. Step 2, list all the given values in the problem. So power rating. So the power of the device is 1500. So that power you must convert into kilowatt, that is 1.5 kilowatt. And the time is given in hour. If the time is given in hour, you must convert into if the time is given in minute, you must convert into hour. Here the time is given in hour. And the price 71.65 cent per kilowatt hour. That is the price of electricity. For 1 kilowatt hour, you have to pay 71.65 cent. Step 3. Substitute the given values into the formula to find the unknown. So cost equal to power rating. Power rating is 1500 watt. 1500 watt you must convert into kilowatt, that is 1.5 kilowatt. Then time is given in hour, so you can multiply 1 hour directly. If it is given in minute, you must convert into hour. Then price is 71.65, that is the price, that is the price of 1 kilowatt hour. So that price you have to multiply there. Then you are getting 107.475 cent. That is equivalent to 1 rand 0.7 cent. So this is a problem. So in some problems you are getting power not directly. So how will you calculate the power? By energy by time also. Energy by time also you can calculate the power. Here the power is given directly, but it is given in watt. You must convert into kilowatt. So that power rating is 1.5 kilowatt and the time used is 1 hour. In 1 hour So time is taking us 1 hour, and the price is 71.65 cent. So what is the cost? For calculating cost, what is the equation? Power rating multiplied by time, then multiply with the price. So you will get the value. So power you must use in kilowatt, time you must always use in hour, and these two multiply with the price. Price here it is 71.65 cent. So total is 1 rand 07 cent. In some question, they will give energy and power. From that you have to calculate the time. So you know that power equal to energy by time. Power equal to energy by time. So time equal to energy by power. So if in a question, if they are giving energy and power, you can calculate the time. Time equal to what? Energy divided by power. So by calculating time, then you can calculate what? The cost, that is power rating. It is given in the question. In this question, that is 1500 watt. And time you can calculate by the energy by power, if the time is not given directly. Then price always will give in the question paper. So multiplying these three, you can calculate the cost of electricity.